Okay, this is the second video. Again, we have our system, and on this video we're not going to touch any commands. We're not going to do anything until the very end, but I want to show the signals that we'll be looking on the next video, video number 3. So we have the assembly. We have brought, or we already supplied the 24 volts AC, and we brought in our 3-phase source. So now we have the AC being adjusted by the variac, and it's going in. So the signals that we'll be looking at is the AC input voltage. We notice that it's 33 right now, and if I were to adjust the variac, I could bring that down. 32, and it's not necessarily to bring it all the way, but there it is, 30 volts. That's by adjusting the variac right here. So that's the output. Now we'll also be looking at the output across the load right here. So we're going to be looking at the AC input, we'll be looking at the DC output, and we're also looking right across the 50 millivolt shunt, and the very last one is just on right across the 34.8 resistor, which is where we get the voltage feedback being fed into the board. We also have your scope, and we're going to be looking at 3 signals. We're going to be looking at test point 5 on the firing board. This is the 60 hertz reference, and we notice that because the board it's already it already has a 3-phase supply, it's already looking at a 60 hertz 50% duty cycle, saying that's the a typical representation of the 3-phase mains input power. We also have the delay angle at test point number 3, and we want to look at the duty cycle of that signal. That will determine the delay angle once we give you a formula. And this oscilloscope is actually giving us the phase shift between signal 3 and signal 1, and it turns out to be this much, which is 134 degrees. We're not going to rely so much on that reading. We just wanted to present it to you. However, you have a 50% duty cycle at 60 hertz. This one will never change, and as we change SIG-high, as we change the commands for the voltage and the current, this delay will move. It will still decreasing. And we are also looking at the DC output. The reason why the DC output is a flat line is because right now the board is inhibited, and it has a red LED, and I'm about to turn it on. Do you see that LED? So I'm going to flip the switch. It's on, and right now we have the minimum output with our setup, and we have 29 volts AC. We have 1.3 volts on our particular setup for the DC output. We have a corresponding 2 millivolt current feedback, and we have 0.13 volts AC for the voltage feedback. All right, so these are the signals that we're going to be monitoring on video number 3. This is the end of video 2.